Am I audible? Good afternoon. Am I audible? BX, are you there? Okay. Mm-hmm. Check. Fine. Can you see the slides? Okay. Now, uh, uh, last we met on Sunday. After that, we had two lectures of BY, and then we had a break for 2 days because there was a webinar. Right. So we got little amount of pending things that are there. I'm a little forgetting whether I've gone through this part or not. This forward chaining, this example. Just see, have I gone through this example? The conflict and all. Just a moment. Hold on. Okay, done. Fine. Just hold on for 2 minutes. हाँ हाँ, मैंने देखा। हाँ हाँ हाँ, कोई नहीं, ठीक। ठीक ठीक, ओके। Fine. Sorry, I got a call from Rati sir. Right. So in case of expert systems, I guess we have reached up to we're supposed to start up from here. Right. Expert system, have we started? Export systems? We have started, right? Yes, we have started. Yes. Please respond. Have we started with export systems? I guess yes. We have started, na? Export systems. So, as far as I do remember, we are supposed to go through the export system shells. Uh, these are uh, these are the representations. Today we'll be touching some of the important parts, right? So this was the example of semantic network, right? In which we had we have a small representation of a semantic net for this car's description. I mean, we do have two varieties of car. This is the frame name, that means Honda Civic or Nissan. These are the two names of the car, which are joined by a is a relationship to a higher order specialized group, that is a car, then again through the same kind of belongingness, that means with an is a to a vehicle, right? And all of them are its attribute values, like the wheels, the engine, and the battery. So these are all its attribute values. You do have a separate attribute value directly related to your uh, semantic network, and the frame name for which the semantic network has been created, like Nissan has got a power steering also. This has can be a user type or can be an instance type if it is within the frames. So since this is a semantic net, we are not talking about the instances, but we do have instances as well as is a relationship for frames. So the same thing, if it is a car, we do have the frame name is car. We do have a frame name of car. We do have the inheritance slot, that means is a, right? Under that, the inheritance name, we do have a value called vehicle, and we do have an attribute slot of engine, right? Again, engine has got certain values associated with it. These are the slots, right? These are the slots. That means within a frame of car, I do have an attribute slot, and this slot has got various values associated with it. As we know that in a frame we can have multiple values associated with it. So in the attribute slot we can have the value as vehicle, and there can be another some numeric values like 1. Now comes another attribute slot, that is the with the name of cylinders, right? So it has got various values depending on the vehicle's cylinder numbers. That means it may be 4-cylinder based car, or it may be a 6-cylinder or 8-cylinder based car, right? Another one is the attribute slot, that means of doors. How many door that particular car, that means our frame does have. So it can be a 2-door car, it can be a 5-door or a 4-door car, right? Likewise, we do have for another one. This is the second claim that we do have. So, working memory. We talked on the working memory part. We do have a set of rules that are given. We do have a set of rules to be proven, and we do have some facts that are given, right? So from the given facts, by use of the rules, the set of information that gets inferred, INFER already inferred, is the set of the working memory. That means the given set of information excluding the rules, as well as the information that is deducted, that is inferred using my given set of information, as well as by using it with rules, with a given set of rules, I can have the working memory for it, right? So we do have it here. We do have a user interface which is directly connected to the user. We do have the inference engine that makes out the decision, and we do have the pure knowledge base. So this is our working memory part. Here you can see the working memory part. Inference engine. Then we talked about this from our handwritten notes. If you want any further clarification on backward chaining, because I talked about the forward chaining, if you want to have the backward chaining, you can see it on the chat. Then I can open up that slide and I can discuss that part right now. Okay. It is also there in my YouTube lectures. If you do there, you will see it. Now this is the last and the theoretical and the most important part of the expert system, that is the expert system shells, right? So basically, if you see the diagram, it is better to see the diagram. We do have the expert, then we do have the knowledge encoding. We do have the knowledge encoding. This green part is the knowledge encoding part. We do have a knowledge engineer out there who encodes the knowledge. Then comes the acquisition, right? Then comes the acquisition. That means how to store and how to acquire the knowledge by use of this knowledge acquisition subsystems. And they are stored in the first initial part. That means the largest information gathering part. We call it as the knowledge base, where the facts, heuristics, and rest all things are stored. From here, we do have the working memory part. This is basically the working memory part, or the inference or the reasoning part. The inference mechanism, reasoning with uncertainty. Here we are given with a set of rules, right? Here we are provided with a set of rules. Now we do have the explanation subsystems. What is the need for the explanation subsystems? I'll be talking about it now. And finally, we do have the user interface, which interacts directly with the user, whosoever is using that particular ES or expert system, right? Knowledge base, we all know they can be in the form of frames, if then rules, that means in the form of the semantic nets, or the prologue rule representations. Now comes the reasoning engine. Now the reasoning engine is all about the if then rules and the case based reasoning. Have I talked about this case based reasoning? Any one of you? Have I talked about this case based reasoning? Have I shown you some of the things? No, no. Well, I'll show you some of the things. Wait, hold on. Reasoning mechanism. Let me tell you, there are two things that are interrelated. Kindly pay attention a bit. We do have, first one is the inference engine, and the second one is that of the explanation subsystems. Yeah, I know that for the time being, I'm just dropping this part, that means the knowledge acquisition subsystem. It is just the part how we are collecting the knowledge by use of the knowledge engineers. This is just acquiring the knowledge, that is building the knowledge base. The important part is the reasoning mechanism. The important part is the reasoning mechanism, and the second one is the explanation subsystem. Now, what are these two things? To understand these two things, first let me show you some of the things, some of the facts that I hope you'd like. Things are a little slow today. Okay, fine. I could have shown you this part, but maybe due to cyclone and all, their websites are not working properly. I could have shown you these are not working properly. Okay. So, in case of case-based reasoning, one of the professors, she's my supervisor too, and there are a lot of others. Those are working in the case of in the area of case-based reasoning. What is this case-based reasoning? We do have a small example for that. Like, uh, let's say I do have an export system, right? I do have an export system. Uh, Now, there is a dialogue that goes on for the car problems. That means it is an export system that interacts with the user for solving the various types of car problems that may arise for a particular vehicle, right? Now, what the system does is it initially asks a question: does the car starts? Then the user says a no, right? This is how a typical export system interacts. The second question that the system asks is, does the engine turn over? The user says a yes. Then again, the system, what is this expert system doing is it is gradually trying to match with its internal set of rules that if the car is not starting and the engine is turned over, then what is the next thing? Gradually, it is moving towards a type of a problem which the expert system is thinking that it is approaching towards, right? So, the second question that the expert system is asking is, do you smell gas? The user says yes. Then the recommendation that the expert system gives is wait for 5 minutes and try again. So at this point of time, as a user, it can have a query that why is the export system advising me to wait for 5 minutes and try again, and it is not saying some kind of solutions to the problem because he might be in a hurry, right? Under these cases, you need to have the explanation for it. Under this, you need to have the explanation. That means why and how it has reached to a type of conclusion. Why and how the expert system has reached to a type of conclusion. The same thing, similar to this, these are somewhat synonymous, right? The reasoning mechanism. That means if the expert system has taken some step, then what is the reason for it? And this is what we have seen in case of a in case of forward chaining and backward chaining solving problems, right? That if you have inferred a particular rule, then how come you have reached to that rule by use of what facts and what set of rules in the working memory you have used to reach for that inference? Okay. So now wait for 5 minutes. So the user asks why. Then the system must be ready to provide an explanation, right? So the rule that has been used to provide an explanation is that if it is not starting and the engine is turned over and the smell of gas is coming up, then the recommendation is wait for 5 minutes. So these are the three things which forces or which somehow advises under these conditions it is advisable that it is better to wait for certain amount of time before moving for any other remedial actions that can be put forward, right? Now, the types of explanation. What are the different types of explanations that you can have? Is how the system has reached to a given conclusion, or why the system has reached to a given conclusion, and why the system is asking. If the system is recommending something, then why? That means we do have one set of how, and we do have two sets of why category of questions that may turn up from the side of the user, for which the explanation can be provided for a particular case of problems. This was for a particular case-based reasoning for the vehicle which is having a problem in starting. So this thing could have been different also in case of medical reasoning. Like if somebody is having various kind of symptoms for a particular disease, then the recommender or the expert system could have come up with some kind of queries like okay, if you're having cough, then for how long, or if you're having dry cough, or it is a kind of different kind of cough, then on the basis of these, the expert system could have recommended some kind of solutions to the problem, right? So this is there. Now the application of expert system. They are obviously, I have many times I've said, they are mostly used for diagnosis and troubleshooting of devices and systems. And second one is planning and scheduling. You plan out or you schedule some kind of tasks, then those kind of things can be recommended by a particular expert system, right? Now, confirmation of manufacture, these are some things. Financial decision making, you have to. I have talked on this, like the Midas formula that I have said you previously while starting during the starting of the export system, right? Then comes knowledge publishing. These are some things which you need to go through if you want. So this part finishes our export system, right? Now, next what we need to see is the next important thing is the natural language processing, or the NLP part. Now, what is a natural language? Now, uh, generally, what happens that we do have in our JVT also, we do have a paid subscription for a wonderful research site that is IEEE Explore, that can be easily accessed from the intranet of JVT. So I'm sure some of you might definitely have seen that. You cannot access the documents or the research articles that are there from your home, but you can definitely access it from JVT or from some other organizations also, those who have paid money for that. So if you're going to type only this word, that means NLP or natural language processing, you're going to find that almost 98-99% of the work that has been done are basically in English language, right? So somehow people have conceived a kind of an idea that natural language processing is just about English. Whereas the fact is that, just a moment, whereas the fact is that natural language is any language. It can be any language, like Hindi, English, Urdu. It can be Turkish. It can be Spanish. It can be French. Anything, any language that a human being uses for communication between themselves, we call it as a natural language, right? This is generally a type of expression or a type of voice or a type of phonemes or a type of phonetics gets that gets conveyed from one individual to another, and this process is what we call it as spoken by people, right? Now, what are the, whatever terms that I've used just now, you'll be seeing it gradually. Now, natural language processing encompasses anything a computer needs to understand. Now, natural language, typed or spoken, and also generate the natural languages. Wait. Now, uh, always it is considered as a subfield of artificial intelligence. Natural language is a subfield of artificial intelligence. Now, here you're gonna see that we do have different types of natural languages like Hindi, English, French, Chinese, etc. They generally comprise of symbols as well as rules. While we talk about the symbols, that means these are the set of symbols, that means characters that are used for that particular language to convey the information from one individual to another. And they are always governed by a set of rules to manipulate those symbols. Manipulation, what do we mean by manipulation of symbol and using of rules? Now, symbols means I do have various types of characters, right? I'll be showing you here first, then I'll again get back there. Like in a formal language, we can have different types of symbols like the alphabets. They can be like this, or they can be in the character set, or they can be numeric as well as character set, or they can be alphanumeric also. They can be the form of string. right? So, uh, but in all the cases, what's going to happen is, like, whenever we talk about rules, then we talk about grammars. That means every language that is spoken is always guided by a set of rules, which we call it as a grammar. English does have a grammar. Hindi does have a grammar. We call it as a vyakaran. Sanskrit also does have a grammar. In fact, all these kind of languages, they do have a set of prescribed rule set, which we call it as a grammar, right? Now, if I talk about natural language processing, then initially, then they can be basically clubbed up under two heads. The two heads are the natural language understanding. The first one is natural language understanding, NLU, right? And the second one is the natural language generation, or NLG. So NLP comprises of two things. NLP comprises of NLU as well as NLG, right? So let us gradually talk about NLU, natural language understanding. It is basically understanding certain concepts, even though the spoken language that we generally use, it is very much ambiguous, right? We do have a lot of ambiguities in our spoken language. All those ambiguities are to be handled very, very precisely. Now, natural language understanding task is like understanding and reasoning while the output is in natural language. Here we ignore the issues of natural language generation. Let me tell you now itself that natural language understanding is far more easier as compared to natural language generation. I'll be explaining all these things now. So, if I'm talking about the natural language understanding part, if I'm talking about the natural language understanding part, then I'm talking about how a system will be understanding the syntax, how the system will be understanding the semantics, how the system will be understanding the morphemes, how the system will be understanding the phonetics, and how the system will be reacting towards the morphology, right? These all things are to be considered, right? So some of the technicalities that I have listed now comes under the category of natural language generation also. But before that, let us know something about NLU. In any kind of uh, system, like can you see the screen now? Can you see the screen now? Hello, are you there? Okay, huh. Now, see, we do have an interactive device like Ella, right? Ella is for SBI's card division. So if I just click it here, then if I type down something, let's say, I'm talking about how to see. The moment I've started typing something, it is uh, it is somehow projecting the kind of questions that I should ask, in fact, or these are the kind of predictions that are given to me that I could have gone for. These are the choices that are available for me. So if I how to do login, now see, I put up a question mark and I have entered it, right? So the moment I wrote this question out here, it came up with my login stuff. Instead of this, if I would have gone straight away from here to here, I would have clicked what is login. Then also the same, exactly same kind of reply would have been given by this chatbot, right? This particular chatbot would have replied in the same way. So the moment I came to this interactive platform, that is a live assistant that they talk about, this is nothing but a natural language interface for knowing the details of this platform called as the SBI cards. Right? So now, what do you think is the basic difference between when I wrote this question and when I wrote this one? What is the basic difference? Uh, can any one of you reply that how the system reacted to these two queries of mine? Any one of you? Can you say something on this? What actually happened when I wrote the whole of the question and when I wrote only a single word out here? Both the words, both the phrases. I mean, the first is a proper question, a query. It has also been read, and the second one is simply a word that I've used, and it has also been read. What is the basic difference that came up here? Any one of you? Can you come up with a kind of a reply? Any kind of reply? Yes, yes. It only picked up the login keyword. Yes, cut down to now. Fantastic. It has only picked up this login keyword. In fact, for the first one also, it hasn't paid any heed to this part. It is immaterial for it. It has only understood this part. In fact, it hasn't understood. So let us get back to our the slide. What it has done there is like it is a kind of flat search technique. Flat search technique means in the whole of the text, if there are certain keywords or there are certain nouns or there are certain verbs or phrases that are already held in my preconceived database that is already there, then the system will be recovering the system will be fetching the information from that set of data, and it will be rendering it to the user who's asking the question. So under these cases, you cannot call it as a natural language interface in all. It is basically a kind of a search. So if you put up some other words also there, like payments, how do I make payments or payments only, then also the answer will remain the same. That means it will fetch you the values for payments itself and nothing else. So under these cases, if you are going to make out some kind of projects later on, let's say in your next year and all, uh, these kind of understandings are restricted to factoid class of queries, right? Factoid class of interactions. What are these factoids? Factoids are like, I'm asking you a question. Am I audible? Is the slide visible? What is the kind of answer that you're going to give? The kind of answer that you're going to give is a yes or a no. But you are not going to say me in detail that sometimes, very rarely, you will come up with an answer and you're going to say me, yes, you are audible, but still it is not so clear, or I'm unable to hear you very properly. So these are called explanatory. That means non-factoid class of queries as well as their answers. Mostly you're going to find that in case of Ella or in case of Disha, any of these interactive platforms, they are only based on factoid replies, right? Now, if I talk about factoid replies, then you can immediately say that the reply that we have seen on the interface is not factoid. It has come up with a whole sort of explanation for how to make out the login, or how to go for the payment details, or how to go for getting a kind of a loan. So it will talk about all the processes, and it is not replying in a single word. The answer is that they are not giving you a reply. They are simply fetching you the table. It is just like an execution of a small SQL query, which can be fired, and from that the information can be extracted and can be rendered in front of you, right? So this is what can be done in case of natural language understanding for very lighter things. Now if we go into the in-depth details of it, like if the questions are of, if there are a lot of questions which cannot be answered in a factoid way, Like if I ask you what is a term called, what is a Hajj? So Hajj is a festival of Muslims from all over the world, and in India also, like what they do in the month of Ramzan and all these descriptions that come up. Or if I ask a question, what is the process of making an omelette, right? You cannot answer these kind of questions in just yes or no. So you need to have certain amount of information to be provided. So what happens during these phases is that you can make a system understand the language, but it becomes utterly critical to frame that language and reply back to the individual by framing unique sentences for that particular query. If I ask you how's the temperature back at your place, and what is the what is the rainfall out there, you cannot simply pick up these values from your web crawlers from internet and you can fetch out those answers for the user. There are a lot of chatbots project that I have seen. People are doing these kind of activities which generally don't support the actual technicality of natural language processing, right? So this is what we talk, what we know about natural language, or what we should know about the natural language understanding part. Now, understandability is a little more complex also than this. Like, as I've already said, you maybe during our initial lectures, like there are kind of questions. If it comes up that there's Mr. X and Mr. Y, those who are the two prime ministerial candidates in India, and if there is a question like, whom do you think, you ask to a kind of expert system or an AI enabled system, that whom do you think is the probable candidate for becoming the 2000 this 23 24's prime minister? So what the system gonna do is definitely it will not come up with the word like he or the second one or the first one. They will come up with certain amount of justifications. That means if they are taking the name of the first individual, that first individual, why it has taken the name of the first individual. Let's say the first individual has opened a few hospitals and schools, and it has taken care of many homeless people. All these justifications will also be drawn from that chunk of information. Okay, now one more thing that I need to talk with you. It's like in natural language processing overall in NLP, what actually happens is you are provided with a text-heavy information segment. Text-heavy means you are having a lot of textual informations. That means it is having a lot of unstructured data. It is having a lot of unstructured information set that is there, from which we have to infer or deduce information in a better way, right? So, let's say I do have a book comprising of 400 pages, there's an Oscar Wilde's novel or whatever, and I need to search out from the Ramayana itself. I need to search out that who killed, what was the process of killing of Ravan, or what was the process of killing of. Just a moment, just a moment. हेलो भाई, क्लोज भाई. हेलो. हाँ सर. हाँ बोलो बोलो, सुनाई नहीं पड़ रहा है साहब सर. हाँ मीटिंग हो गई ना, हाँ. Huh. So we had a talk on natural language understanding, right? Now, the next one is like natural language generation. So for those kind of questions where you cannot, the things cannot be replied in one word, then what we need to do is we need to come up with the natural language generation part, right? We need to come up with natural language generation part. That means it will look more realistic if we are going to put up a reply in the form of natural language generation. So NLG is the again a sub part of natural language processing itself, and it is basically the area of text generation. The basic problem that comes up with text generation is modeling the particular sentence according to the need of the computer, so that it becomes for the system to make it human understandable. They must follow all the grammatical rules, and they are to be prepared on real time basis, on the real time basis for replying back to the user. For that, we need to have the natural language generation part, right? So natural language generation, the work on natural language generation is a kind of a little critical, on which very less amount of work has till now been done. So in this case, what happens is you do have an input in the form of natural language, and you expect natural language output also in case of natural language generation, right? And this overall process, we call it as the natural language processing, which comprises of the understanding as well as that of the generation part. Now, now comes these things, symbols we have gone through. This is something important. Now, the linguistic and the language processing, if we talk about, they are basically based on the phonology, they are based on the morphology, the syntax, the semantics, and the pragmatics, right? Now, the levels of linguistic analysis is as shown below. They can be categorized as speech recognition part or natural language processing part. So this bracket that you can see here is speech recognition, and this part starting from morphemes, you're gonna find it is basically natural language processing part. Now, when we talk about the speech recognition part, that means we talk about the phonetics. Phonetics about production of speech, reproduction of speech, in fact, by using various kind of vocals. In fact, vocal sounds. Now, the next one is the phonology. That means the sound patterns, the intonation, the pitch, and all these kind of things. These things are important in case of the linguistic analysis. Next comes the lexicons. Lexicons are nothing but the smallest bit of understandable, the smallest bit of unit that is understandable in a particular language. In our case, we'll be taking it as default as English, right? The smallest bit, like what is the lexicon in this part? The lexicon is, there are many lexicons like dictionary, or it is of the words, and in a and a language, right? Now we do have the morphemes. This is called as the overall information, right? The morphology. Now the word formation and structure, further structuring. Next comes, now from here itself, the natural language processing begins, like the syntax. Syntax means the actual grammatical structuring of the sentence. Whether the sentence is grammatically correct or not, we check in case of the syntactic analysis. What happens in case of semantics? Now, whether it does have any kind of proper intended meaning of that particular piece of sentence or not, whether they do have a particular meaning or not, or they are grammatically correct but they don't infer any kind of information to us. So syntactic and semantic analysis are an integral part of natural language processing, right? Then comes the pragmatics. That means it is about understanding the external and internal info both. Like there are some of the things that are not explicitly said, but they are implicitly understood. So this is called as the language pragmatics. We'll be seeing about them here. Now, we do have the steps in natural language processing. The first one is the morphological and lexical analysis. That means going on to the lexicon part and seeing its morphology. lexical analysis, it aims to divide the text into paragraphs. And basically what we do to reach for a lexicon, what is the normal process that you can do is you can break the overall paragraph into sentences and sentences into words, and then you can go for a lexical analysis. That means it is the smallest part of analysis of which you can go, that means up to the word level, right? Next comes as the syntactic analysis. As I have already said, that boy the go the to store, this is a syntactically incorrect sentence, and this kind of inputs will be rejected by the syntactic analyzer within the natural language processing toolkit. Now comes the semantic analysis. Colorless green ideas, even though this is syntactically correct, but semantically it is wrong because it doesn't give any kind of information whatsoever about the grass or the ideas or the color, right? So these kind of sentences can also be rejected by the semantic analyzers within the natural language toolkit. Comes as the discourse integration, right? Discourse integration is about when we talk about the word it in the sentence. We all know that if we are talking about, like, if we say, okay, Ram is a good boy, full stop, there is a delimiter called full stop, and in the next sentence, after a space, we start up with Ram is a good boy. He plays a wonderful violin. He plays the violin in a very nice manner. So here the he is referred to the Ram itself, who's there in the previous sentence. Likewise, uh, keep this pen beside it. And if I instruct you, like, you can see a bottle on the table, and please keep the pen beside it. In this case, the it is being referred to the bottle. You can easily interpret and infer this information that here this word it is referring to that of the previous noun object class. That means we are talking about the bottle, right? But how to make the system understand about these kind of details? Now comes as the pragmatic analysis. What is this pragmatic analysis? Pragmatic analysis is all about handling the common sense information. Do you know what time it is? It is a kind of requesting tone for knowing information. So it could have been straight away asked, like, what is the time, right? So instead of that, we have asked this for both the questions, the answer would have been same. But as a human being, we can understand that this question as well as the question that I've said, what is the time, would have been uh, the same thing. But for a system, they may not be able to understand what is the basic difference between them, right? So I'll be talking about all these things. Okay, one more thing is left out here, that when you talk about speech recognition part, then mostly this thing comes in, even though this is a computer science part, but there are a lot of EC people those who work on this area. We do have very, very specific or specialized toolkits that are available. Not toolkits, sorry, a kind of, yeah, kind of, what should I say? Uh, a kind of tool that is available. We call it as this MATLAB. MATLAB is very, very common for these kind of analysis. Many of you have known what MATLAB is. Can I get the reply from your end whether you heard this word MATLAB or not? I've asked this question to your previous batch also. Have you heard what is? Okay, good. So those of you who know what is MATLAB, then you might have definitely seen that they have got special packages for speech processing also, like for introducing any kind of voice clips. They generally permit the wave format. They generally permit the wave format because there are no noise in it and there is no loss of information in case of wave format files. So then you can put up, you can just pick those packages up from there for any kind of analysis on the speech segment. Now, speech recognition has got one more application. Generally, the applications that you might have known, those are very common, like opening up a system by using your own voice. That is what we call it as a voice recognition module. There are a lot of systems that goes by using voice recognition module. So in case of voice recognition module, there are pre-recorded some set of informations, like open the computer, or I'll be uttering certain amount of text, and that thing will be stored for 4, 5, or 6 times, as we generally do for saving our fingerprint password in our mobile phones, right? And later on, when you will be speaking to it, it will simply verifying your voice quality. That means pitch, intonation, wavelengths, and all these things with the already stored pattern that is there in its database, and then it can allow you an access or it may deny you an access, right? But there are some of the critical applications of speech recognition also. The critical applications of speech recognition are like you can have that's what I was going to show you in our one to work, but site is not opening up. Site is not opening. Whatever the case may be. Hey, do one thing. We do have almost 55 minutes to 1 hour. You can take up a break of 10 minutes, but it should be definitely 10 minutes. It is around 3:25 now. It is around 3:25 now. You come back by 3:35, huh? We'll start up the class again from there. Come back at 3:35. Come back at 3:35, right? Hold on, before you go, Agam, are you there? Or Harshit Purvar, any one of you? Agam, are you there? Agam, are you there? Acha, Harshit, you're there, right? Harshit, just take up the screenshot of now and store it as like 23rd May from 2:30 to 3:30. Just save it, huh? Please take the screenshot of the attendance and keep it with you. I'll be needing it maybe tomorrow or day after tomorrow, right? Just keep it, and then after Harshit says to go, then you can go and you can again come back at 3:35 or 3:40. Be relaxed and come up slowly, right? Done. Okay, fine. You can go now and come back in the next 10-15 minutes. We'll again start up from there.